Riemann-Tiemann reaction. So when alcohol reacts with chloroform in the presence of sodium hydroxide, so the alcohol, the phenol will convert it into a salicylaldehyde. Salicylaldehyde means CHO group will be introduced on the ortho position. So you will get a salicylaldehyde. Okay, so Jubita has also joined the session. Good evening, Jubita.
Good evening, ma'am.
Okay, so Jubita, you were not in the previous class, so we have already finished the chemical properties of alcohol as well as the phenol. Only two chemical properties or chemical reactions were left, so which we are discussing it today, which is Riemann-Tiemann reaction and the Kolbe's reaction. Okay, so you will get the notes, you will get the recordings. Just please go through the recordings, and if there is any doubt, just let me know in the next class. Okay. So Riemann-Tiemann reaction. So when phenol reacts with chloroform, okay, what is chloroform? CHCl3. In the presence of sodium hydroxide, means in the basic medium, this reaction occurs. So here on the ortho position, so suppose this is your, so basic reaction kya hota hai? This is your phenol. This is your phenol. So in the presence of CHCl3 and sodium hydroxide in the basic condition. And in the second step, we just do the acidification. We just add acid. Okay, so you will get a salicylaldehyde. So the conversion, what is the Riemann-Tiemann reaction? So the conversion of phenol into the salicylaldehyde. Salicylaldehyde. Okay, and in the presence of chloroform and the sodium hydroxide. Okay, so just remember that. Phenol to salicylaldehyde. And now what is salicylaldehyde? So this is a OH, this is a phenol. So on the ortho position, you have to introduce the CHO group. CHO group. So this is your salicylaldehyde. Salicylic acid, just remember what was salicylic acid? So this was your OH phenol group, and ortho position pe kya hota tha? COOH. So this was salicylic acid. This was salicylic acid. But this is salicylaldehyde. On the ortho position, there is a aldehyde group, CHO group is present. So that's why, what is the name of this? It's a salicylaldehyde. Dehyde. Okay, and what will be the IUPAC name of this salicylaldehyde? Can anyone tell me? Yes, Muniba? Yes, Safrina? Yes, tell me.
2-hydroxybenzoic.
Yes, very good. So you can benzoic acid, nahi, it is a benzaldehyde. It's an aldehyde group, right? Benzene pe kya attached hai? Aldehyde group. So you will call it as a benzaldehyde, right? So it's a benzaldehyde. If it is COOH group, then you will call it as a benzoic acid. Okay, then it is benzoic acid. So what will be the name? So basically, you will start the numbering from here, 1, 2. So you can write 2-hydroxy benzaldehyde, or either you can write ortho, because here ortho position में aldehyde group is attached, right? So ortho hydroxy benzaldehyde. Benzaldehyde. Okay. Okay. So Aisha has already joined. Hello, Aisha. Why are you late, Aisha?
Ma'am, my Zoom started updating.
Okay. Okay. So we have started the Riemann-Tiemann reaction. Okay. So Riemann-Tiemann reaction is basically the conversion of phenol to your salicylaldehyde. Okay. So ortho position pe you have to introduce the aldehyde group, CHO group, in the presence of, and this reaction occurs in a basic medium and in the presence of a chloroform. Okay. So what is the reagent over here? CHCl3. Okay. Chloroform and sodium hydroxide. So in the presence of chloroform and sodium hydroxide, this phenol will convert into the salicylaldehyde. And the other name of salicylaldehyde is orthohydroxybenzaldehyde. Okay, and in your exam, from this topic, which type of question can come? Like question किस type से पूछा जाएगा? So either they can give the direct name, what is Riemann-Tiemann reaction, or sometimes they will give you how you will convert the phenol to salicylaldehyde, or how you will convert this phenol to orthohydroxybenzaldehyde. Okay, ortho hydroxy भी दे सकते हैं वो, or either 2-hydroxybenzaldehyde, both are same. Okay, so this is the Riemann-Tiemann reaction. Just add the chloroform and sodium hydroxide, and in the second step, you have to do the acidification reaction. Then you will get this salicylaldehyde. On the ortho position, you have to introduce the CHO group. Is it clear?
Yes.
Yes. Now, the mechanism is very important. Okay, now try to understand the mechanism step by step. So, how this reaction occurs and in which step what will happen? Let's see. So first step में क्या होगा? This is the phenol. This is the phenol. When you add CHCl3, this is CHCl3, chloroform. So it will create a intermediate. It will basically create CCl2. CCl2 ये introduce कराता है ortho position पे, right? So this CHCl3 will give you CCl2, this radical basically. This is a, and this will help in the formation of intermediate. This will form intermediate, and due to this intermediate, your reaction will proceed, and there will be a aldehyde group on the ortho position. So वो basic role किसका होता है? The important role is of your chloroform. So chloroform is responsible for the proceed of whole reaction. It will proceed the whole reaction, and it will give a CHO group on the ortho position. Okay, so let's see what will happen. So when you add CHCl3 in the presence of basic medium, NaOH डाल रहे हो आप, aqueous NaOH. So what happens? See, when you give NaOH, so what happens? This hydrogen from here and these two OH group, because it will dissociate to Na plus and OH minus. Okay, and this is again O minus here and H पे positive charge. So this will combine and यहाँ से water liberate हो जाए. H2O will form. So this hydrogen from the phenol and this NaOH, okay, OH from the sodium hydroxide, they will combine and they will liberate as a water. They will remove as a water. So यहाँ पे dehydration हो जाता है. Okay, and no need to write down the byproducts here. Just write down the major product only. So what happens over here? So, and sodium, because the oxygen पे क्या आएगा? Negative charge, and the sodium will have the positive charge. So this sodium will attach over here. So it will form O minus and Na plus. Okay. Now this CHCl3, in the same step, you are adding the chloroform also. So this chloroform will introduce here the CCl2. CCl2. And because to complete the valency, you have to add one hydrogen over here. So CHCl2 over here. You have to introduce on the ortho position CHCl2. Is it clear? First step.
Yes.
Okay. Now, second step. So this is basically your intermediate. Your intermediate. This is your intermediate. Third step, when you again add the sodium hydroxide. So sodium hydroxide is again present. So what happens over here? This ONA as it is. And what happens over here? This sodium, so here NaOH. So 2 moles. If you take the 2 moles of NaOH, so what happens? OH, okay, 2 water molecule, 2 OH. 2 OH will come over here. So from here, sodium, 2 sodium and 2 Cl. Okay, 2 sodium from here and 2 Cl. They will combine and they will form 2 NaCl. 2 NaCl. And this OH, because 2 OH bhi hoga, so this 2 H will come and attach on this carbon OH, and here again OH. Here again OH. And you can just write down like this. This is your H, and this is your, and this was this hydrogen as it is. Again, I'm just repeating this step. What happens when you add again 2 NaOH. 2 NaOH के presence में क्या होगा? This Na पे positive charge and OH will have the negative charge. Now this chlorine will have the negative charge and it's a good leaving group also. So from here these two chlorine will come, okay, and they make bond with the sodium. And यहाँ से क्या होगा? NaCl. 2 NaCl will be removed. Will be removed. And what about this OH? So again, there are two hydroxyl group. So two hydroxyl will attach on this carbon. Okay. So carbon पे दो hydroxyl group attach on this OH group over here and OH group over here. Is it okay? Got my point?
Yes. Yes, ma'am.
Now,
Yes.
now see, what is this? This is OH and this is hydrogen. So this oxygen will have the lone pair, so it will try to abstract this hydrogen and ये यहाँ से water release हो जाए. This H2O will be released from here and next step will be your ONA. And here what happens? Here it will have COH group. Okay, so you can see the aldehyde group has been introduced on the ortho position. Okay, now what you're supposed to do? This is O minus and this is O Na plus. Again, just do the acidification. Just add the acid. Suppose we have added the HCl. So HCl will have the positive H plus and Cl minus. Now this is a sodium plus. So sodium plus will combine with chlorine minus and they will liberate as a salt. Salt remove हो जाएगा. Okay. So salt will be formed and NaCl will be formed and this H will have the positive charge. So it will come and attach on this oxygen and you will get OH over here. Just a second. Let me write again. Now it will form salicyldehyde. Salicyldehyde. This is a OH and here on the ortho position there is a aldehyde. So this is your orthohydroxybenzaldehyde or you can say salicyldehyde. So salicyldehyde. So that's the step. So that's the whole mechanism. Step by step, you should know what's going on, and that's how you have to write down in your exam. And no need to write down the HCl remove हो रहा है, sodium chloride remover. Just write down the main product. No need to write down the byproduct. Okay, but in your mind, you should know what is happening over here. Okay, because sodium is having positive charge, so it will combine with the chlorine of the HCl and it will liberate as a salt. Okay, salt की तरह remove हो जाएगा and this oxygen will have the negative charge. So here the hydrogen will come and attach over here and it will give you a salicyldehyde. Clear to everyone?
Yes, ma'am.
Okay. See, if there's any doubt in any step, just please let me know because these are very very important. अगर आप ऐसे ही जाने दोगे तो it will be very difficult for you to write down in your exam. Okay, so just try to understand the mechanism step by step. याद नहीं करना अभी. This is a chemistry. Chemistry is not for memorizing. Okay, it's the concept you should understand. Step by step, you should understand the concept and don't learn the mechanism. Just try to understand the mechanism step by step. Okay, so it is clear the whole Raymer-Timan reaction. So phenol, it's being converted into the salicyldehyde. Okay, in the presence of chloroform and the basic medium, sodium hydroxide. Second is the Kolbe's reaction. Okay, I have already discussed this. Kolbe's reaction. Do you remember where I have discussed this? Kolbe's reaction. I have discussed the preparation of aspirin, right? Salicylic acid. So that's where I have discussed this already. So what is Kolbe's reaction? So Kolbe's reaction is when you convert the phenol to your salicylic acid. So Raymer-Timan reaction क्या था? Phenol से salicyldehyde. Okay, salicyldehyde. But this Kolbe's reaction is the conversion of phenol to salicylic acid. Salicylic acid. So what happens over here? Kolbe's reaction is a reaction when sodium phenoxide ion is treated with carbon dioxide at around 400 Kelvin and 4 to 7 atmospheric pressure. So here sodium salicylate is formed, which on further acidification gives a salicylic acid. So that's the whole process, which will be in coal-based reaction. Now let's see the mechanism. First, we will see the reaction. So see what happens. This is your phenol. So when you add sodium hydroxide, so first we have to prepare the sodium phenoxide ion. Sodium phenoxide कैसे बनता है? So we have repeatedly we have discussed this so phenol when you convert this phenol to sodium phenoxide. When you add sodium hydroxide, it will give you sodium phenoxide, right? So from here, water will be released, H from this phenol and OH from this sodium hydroxide. And यहाँ पे क्या आ जाएगा? There will be a O minus and Na plus. This is your sodium phenoxide. This is the sodium phenoxide. Now the next step is when you treat the sodium phenoxide with carbon dioxide. Okay, so carbon dioxide at 400 Kelvin temperature and atmospheric temperature is 4 to 7 atm. Okay, so next step will be, so what happens, the sodium will be removed from here. This sodium, not, it will not be removed. Basically, you have to introduce the CO2 group, C double O group, carbon dioxide group, between this oxygen and Na plus, between this O minus and Na plus. So how you will introduce? This is oxygen, and you will just add CO2. It's the carbon dioxide, CO2. CO2 you will introduce between the oxygen and the sodium. And after this, you will add Na. So that's the intermediate over here. So it has a Learnivio 1, 2, 3, 4, right? So is it clear this is step? How you will introduce a carbon dioxide between oxygen and sodium?
Yes, ma'am.
Next step. Next step. See, this is little bit tricky. So you should remember this. So here there will be a reversible process or rearrangement, you can say. There will be a rearrangement because there is a bulky group. This is a bulky, COONA is a bulky group. So it's quite unstable. So for the stability condition, this COO, this group, this whole group, it will rearrange itself on the ortho position. ये कहाँ पे आ जाएगा? ये oxygen, this bond will be break and this COONA group will be introduced on the ortho position. So see, O minus you can write because this bond is being broken. And here this COON. Is this a step clear?
Yes.
Next step. So yeah, next step will be just do the acidification. Just add H plus ion. If you add H plus ion, so from here sodium will be removed. Okay, यहाँ पे O minus है, Na plus है. This will be removed and H यहाँ पे भी आ जाएगा and H यहाँ पे भी आ जाएगा. And both the oxygen H will comes. दोनों ही yeah OH. Okay, here the hydrogen will attach and again here H will attach. So what is this? This is a COOH. Okay, so what is this? This is your phenol. When the in the phenol, when the on the ortho position there is a carboxylic acid group, COH group. So it is known as salicylic acid. It's a salicylic acid. So that's the whole mechanism. That's how you will convert the phenol to the salicylic acid. So the intermediate steps, this third step, you should keep in your mind. This is very important. यहाँ पे आप गड़बड़ कर देते. This step is important. You have to rearrange that. For this COONA group, you have to add on this position or the position. Okay, because at last we are just converting this phenol to the salicylic acid. And what is salicylic acid? It's a hydroxy, right? Ortho hydroxy benzoic acid. So because you are just telling this is a benzoic acid, right? Acid आप बोल रहे हो, तो acid को you will just take it as a parent chain. Okay, so you will start the numbering from here. Okay, so this carbon you will number it as 1. Then this is your second. Okay, so this is the second. आप second hydroxy पे बोल सकते हो 2 hydroxy benzoic acid, or it is ortho hydroxy because as compared to this is the ortho position. So ortho पे hydroxyl group is attached. So this is your ortho. This is your orthohydroxybenzoic acid. So again, in your exam, they can give you anything. Like they can ask you the by the name reaction, Colbase reaction, or sometimes they will indirectly ask you like convert the phenol to the orthohydroxybenzoic acid or salicylic acid. So that's how you will convert this. Clear to everyone?
Yes, ma'am.
Okay. What about others? Aisha, Jupita, is it clear, bachcho?
Yes, ma'am.
Okay. Next is methods of preparation of ethers. Okay, so the next is your methods of preparation of ethers. So first I'm just covering this methods of preparation of ethers, then physical properties की बात करेंगे हम. After that chemical properties of ethers. Then two topics is being left, which is some commercial alcohols, important alcohols. So in that we will discuss the your ethanol and methanol. उसकी properties की बात, how you can prepare the ethanol. Okay, commercially how you will prepare, what are the uses, etc. We will talk about. And one more thing, distinction test. Distinction test between the primary, secondary, and tertiary. Other than leucastis, there are two more tests: iodoform test and your ferric chloride. So these two tests we will discuss. So it will take today class, and inshallah in the next class I will complete this chapter. Okay, I will complete this chapter in the next. So please just revise it repeatedly. Okay, and if there is any doubt, just ask me. Just clear your doubts. Okay. So method of preparation of ethers. So how you can prepare the ethers? First method is dehydration of ether. Dehydration of alcohol. By dehydrating alcohol, you can prepare ether. But it depends on the temperature. See, it's totally depend on the temperature. If you give high temperature, very high temperature, so here in that case the dehydration will occur. Okay, basically dehydration will occur and you will get the elimination reaction. Elimination reaction hoga at the high temperature, and you will get alkene instead of ether. So it totally depends. Dehydration of alcohol totally depends on the temperature. See this reaction, this CH3CH2OH, primary alcohol. We just take primary alcohol and उसमें हमने क्या डाला, H2SO4, sulfuric acid. But the temperature here is 443 Kelvin. Okay, so at 443 Kelvin, so it's a quite high temperature. So here the elimination reaction will occur. Elimination reaction hoga, right? Means alpha positions, alpha carbons, OH hydroxyl group will be removed. And from the beta position, from the beta carbon, one hydrogen will be removed, and it will give you CH2CH2, which is the alkene. Okay, but when you do the same reaction, okay, when you are using the same reagent, but the temperature, there is a temperature difference. Now you are using 414 Kelvin, 414 Kelvin only. So at that temperature, there will be a substitution reaction, not the elimination reaction, right? Substitution reaction hoga. And what is substitution over here? So one hydrogen will be removed. It will be one hydrogen will be replaced by this whole group. यहाँ पे क्या होगा? Suppose this is your CH3. See, just a second. CH3 से नहीं explain करती हूँ. Just a second. Yeah, suppose this is your ROH. Okay, and you are just adding H2SO4 at 414 Kelvin. If the temperature is this, so here the substitution reaction will be there. So hydrogen will be removed, will be replaced by this group. Okay, suppose this is this R group, anything R group kuch bhi hoga, so you have to attach this R group on the right side of this oxygen also. So you will get ROR. So this is your ether. What is this? This oxygen linkage is the ether linkage, and on the left as well as on the right side, both side पे क्या होगा? Same alkyl. So and that alkyl group is this. So आप जो भी reactant में ले रहे हो, any alkyl group. So this is your CH3CH2. So here on the right side you will attach the CH3CH2 again. If it is CH2 only, CH3 only, so you will attach on the right side of the oxygen linkage, you will attach CH3, right? So Suppose this is CH3OH. So when you using the same reagent, so substitution hoga and you will get CH3. This is the oxygen and hydrogen will be replaced by this group. So here again you will attach the same group, the same alkyl. Again, if you are just adding C2H5OH, C2H5OH. So here again, this hydrogen will be replaced by C2H5 oxygen, and here again you on the right side of the ether linkage, you will again write down the C2H5. Means you will get the symmetrical type of ether. Okay, you will get the symmetrical type of ether in the dehydration of alcohol. Is it clear to everyone?
Yes.
Yes, ma'am.
Yeah. Okay, so let's do some questions. Yeah, so just learn the temperature. 443 Kelvin hai in the, if the reagent are same, H2SO4 plus 443 Kelvin. So here the elimination will up. Elimination hoga high temperature pe and you will get the alkene. But if the temperature is 414 Kelvin, so here in this case, you will get the substitution product. Okay. Now, so ethers having same alkyl group on either side of oxygen atom is called symmetrical. You know very well. Okay, so this is oxygen linkage, and if the ether both side the alkyl group is same. So if here it is CH3, so again here it is CH3. So this is a symmetrical type, means oxygen linkage is this. This is the ether linkage, oxygen linkage, and on the right side as well as on the left side, both have the same alkyl. Okay, so this is your symmetrical type. And what is asymmetrical type? Asymmetrical is, suppose this is your, both the alkyl group are different. So here on the right side, on the left side, the alkyl group is different. This is asymmetrical. So dehydration of alcohol with concentrated H2SO4 at 414 Kelvin will gives you symmetrical ether. Now, here's the three questions. Just quickly do that. Just write on the product. Yes, Safrina. First one. Safrina, what is the first product?
1 minute.
Yes, you have not done. Aisha?
CH3 OCH3.
Yeah, good. And Jubita, second product. Jubita, are you there? Tell me the answer. Second answer. No. Safrina, second one.
CH3, CH2,
Yes.
OC, O,
O,
O, CH3.
O only CH3.
Oh, sorry, yeah.
Are you sure? I just told you it will give the symmetrical type of ether. So this is your see, this is the OH group, and here there are CH3 CH2 group. So you will attach the on the right side of the ether, you will attach the same group. So you will attach CH3 CH2. This thing. CH2 CH3. Right? This thing. So this you will get a symmetrical type of ether. It's very easy. Yeah, Muniba, next one.
CH3, CH2, CH2, OH, O, and then the same thing. CH3, CH2.
Yeah, it's very easy. You guys are making it complicated. It's very easy. Now see, let's understand the mechanism, how it occurs. So first step, suppose this is your reaction. CH3, CH2. We are just taking the ethanol. Ethanol in the presence of H2SO4 at the same temperature, 414 Kelvin. So it will give you a substituted product. Symmetrical type of, yeah. So first step will be the protonation of alcohol. First step में क्या होता है? There will be a protonation of alcohol. So again, it will be here oxygen के पास क्या है? There is a lone pair. So everything depends on this lone pair. So what happens? CH3, CH2, OH. So oxygen has a lone pair. So what happens? This H2SO4 will give you H plus ion. H plus ion. So what happens? This oxygen has a lone pair. So it will try to abstract this hydrogen. H plus है तो इसे abstract कर लेगा. And it will form CH3, CH2, and your oxygen, hydrogen, hydrogen. And you can see oxygen can accommodate only two bonds, but there is a three bonds over here. So on oxygen there will be a plus charge. On oxygen there will be a plus charge. Now this is quite unstable. So ये बहुत ही unstable. So what will happen? So from here this dehydration will occur. This bond will break, and यहाँ से water will be released out. Right, and if water will be released from here, H2O यहाँ से निकल जाएगा, so there will be a positive charge on this. There will be a positive charge on this carbon. Okay, means there it will form carbocation. It will form here carbocation. So when this will be basically, you can't say that it will form the carbocation because it occurs via SN2 mechanism. And in the SN2 mechanism, it occurs only in one step. It's a one-step mechanism. So whole the process will occur in the first one step only. The attack of nucleophile, okay, the basically the release of this protonation of alcohol, and here on this carbon there will be a positive charge. So how you will show it? So this is your, yeah. So this is your CH3. Just a second. CH3. Okay, don't show here. We will show it in the next step. Because here the formation of carbocation will not take place because this whole thing occurs via SN2 mechanism. So you can't show the formation of carbocation over here. CH3, CH2, and O, hydrogen, hydrogen, and plus. So you know in the SN2 mechanism क्या होता है? There will be a attack of nucleophile, okay, and the basically breaking of bond and the attack of nucleophile both takes place in the same step. Okay, so what happens again? This alcohol will come CH3, CH2, OH. Again, it has a lone pair. What happens? This will attack because this when this bond this will release because this is quite unstable. So it will leave. It will leave the molecule. And what happens when it leaves the molecule? So this carbon will acquire partial positive charge. Partial positive charge. So due to the partial positive charge, this not OH, only oxygen which has a lone pair, it will attack this nucleophile. It will try to basically it will act as a nucleophile. This OH group, okay, this OH group will try to act as a nucleophile and it to attack on this carbon. It will attack on this carbon. So here you will get CH3, CH2, oxygen, oxygen, and here again this is your CH3, CH2 and CH3. But here the hydrogen is present, right? Hydrogen is present. So again, you can see there are three bonds. So this is quite unstable. So this will have the positive charge. So oxygen कितने bonds बना सकते? Two bonds. But it has three bonds. One, two, three bonds. So it will have positive charge. Now in the next step, second step, again I'm repeating what happens. First step will be the protonation of alcohol. Okay, alcohol have OH group, or oxygen has a lone pair, so it will abstract the hydrogen. Okay, H plus ion. So H plus ion kahan se aayega? H2SO4 acid se. Acid will give H plus ion. So it will abstract this hydrogen. Okay, and here the protonation of alcohol will be done. So OH2 plus, and it is quite unstable. So what happens? It is unstable. So from here the bond will break. So ये leave कर देगा, and when it leaves, so at the same time this carbon will acquire partial positive charge. Partial positive charge, and this OH group, it acts as a nucleophile. So here this oxygen will attack the carbon which will have the positive center. Okay, partial positive charge, and here this will be formed. Okay, you can see same group is on the right side as well as on the left side. Now, third step will be the deprotonation. Here, what happens? There is a hydrogen. So what happens? The hydrogen will be removed from here and the bond will be unstable. The molecule will become unstable over here. Now, so CH3, CH2, and this is oxygen, hydrogen over here plus charge, CH2, CH3. So what happens? This hydrogen will be removed due to instability condition, and this bond will shift over here. When this bond will shift over here, so ये क्या होगा यहाँ पे? It will form CH3, CH2. Here the symmetrical ether will be formed. This is your product, and that's the whole mechanism. Clear to everyone? The whole mechanism, each and every step.
Yes.
What about others? Aisha, Jibita, Safrina?
Yes.
Okay. Aisha, is it clear? Yes or
Yes,
no?
ma'am.
Are you sure?
Yes, ma'am.
Okay. So this whole thing occurs via SN2 mechanism. And you know, bimolecular nucleophilic substitution reaction occurs in the single step. Right? Means single step का meaning क्या है? यहाँ पे मैंने break कर करके दिखाया 3 steps. So it occurs via SN2 mechanism. Means a single step means the living group will left. Okay, and the attack of nucleophile will occurs in the same step. Single step में होगा. So that's a nucleophilic substitution reaction. Bimolecular nucleophilic substitution. And you know very well SN2 mechanism का rate of reaction क्या होता है? Primary में सबसे fast होता है, then secondary, then tertiary, right? So the rate of reaction will be very fast. It follows this order. CH3 methanol में सबसे fast होगा. After that, primary alcohol, then secondary, then your tertiary alcohol. This is the rate of reaction, the order of rate of reaction. Okay. Now the secondary alcohol and the tertiary alcohols give significant amount of alkene with ether as they are more hindered. Because see, primary alcohols to dega, but secondary and tertiary alcohols, they just give a significant amount of alkene also. Ether के साथ साथ वो alkene भी देते हैं, right? Because they are more hindered. They are more hindered because here you can see in the secondary and tertiary alcohol, there are more CH3 groups. And CH3 group क्या होते हैं? They just show plus I effect. Okay, they just show plus I effect. So due to that, they are very hindered due to the large bulky group. You can say there are more bulky group due to the presence of a bulky group in the secondary and tertiary alcohol. They are very much hindered, and due to the more hydration, you will get a alkene plus the ether. Not only alkene, you will get a ether also. दोनों आपको mixture मिलेगा. So that's why this is not suitable for the preparation of symmetrical ethers using secondary and tertiary alcohols. Okay, so when you are preparing the symmetrical ether, so it is not suitable to use secondary as well as tertiary alcohols due to more hydration. Because in the secondary and tertiary alcohols, there is more CH3 group. More the CH3 group means they are more bulky group. If the bulky group is present, so they will hinder. They will hydration होगा वहाँ पे, steric hindrance होगा. Due to that, you will not get the desired thing. You will not get the desired thing, which is only ether. You will get a mixture of ether and alkene. Got my point?
Yes.
Yes.
Next thing, this method of preparation is not suitable for the preparation of unsymmetrical ethers also. Why? Because it would require two different alcohols. Because if you are preparing because here starting में हमने क्या देखा था, when you are preparing the, it will give you the symmetrical type of ether. But what about when you have to prepare the unsymmetrical type of ether? So this method is not suitable. This method, this dehydration of alcohol is not suitable for the preparation of unsymmetrical ether. Why it is not suitable? Suppose we have this CH3CH2O. Okay, here the ethyl group on the oxygen, the left side of the oxygen is ethyl group, and here on the right side alkyl group is present. Sorry, methyl group is present, right? So you can see it's a two different alkyl group which is present on the right as well as on the left side. Okay, so this is a unsymmetrical type of ether. So unsymmetrical type हम कैसे बना सकते हैं? Not by this method, because this method will give you always the symmetrical type of. So why we can't use? Because here in this case you will require two different alcohols. First is your ethyl alcohol, ethanol, and the second one is your methyl alcohol, methanol. Okay, so when you combine these two, so suppose this is your ethanol plus methanol. आप इन दोनों का react करा रहे हो. Okay, when you are reacting these two in the presence, again in the presence of the same reagent H2SO4 and at the same temperature 414 Kelvin. So what happens? You will get a mixture. You will get a mixture. So what happens? First step में क्या होगा? You will get the hydrogen will be removed and you will get this oxygen and here this. So this symmetrical ether you will get. Similarly, after that, this CH3, it will give you CH3 oxygen and here the CH3, again the symmetrical type. And third one will be your the mixture of these two. Here you will get this one. You will get the unsymmetrical type of ether. So see, you are not getting the only the desired thing because you have to prepare the unsymmetrical ether only. Okay, इसकी जरूरत ही नहीं थी, हमें symmetrical हमें बनाना ही नहीं था. But you get the mixtures of these three. Mixtures of these three. So that's why this method of preparation is not suitable for the preparation of unsymmetrical ether. This is only for the symmetrical type of ether. Yeah, because if you try to make the unsymmetrical type of ether, you need two different alcohols. And when you react these two different alcohols, you will get a mixtures of ethers. Okay, mixtures of two unsymmetrical ethers you will get, and the third one you will get a two symmetrical one, and the one you will get the desired thing, which is unsymmetrical. So that's why this method of preparation is not suitable for the preparation of unsymmetrical ether. Because at last we have to क्या करना होगा आपने purification करनी है. You have to do the purification because the main desired thing is this. You need only this unsymmetric one. इन दोनों की कोई need नहीं. So at last you have to do the purification. So that's why this method of preparation is not suitable. Clear to everyone?
Yes, ma'am.
Now the question is से कैसे आते हैं? So see, this is the question. That's how they can ask you the question. Can you explain why bimolecular dehydration is not appropriate for the preparation of ethyl methyl ether? So what is ethyl methyl ether? This is the example. This is your ethyl methyl ether. Okay. So you can just explain this point. You can write down whole this 3 point आप पूरा लिख सकते हो exam में, examples and this reaction. Yeah. So that's how you can just explain. Next. So second preparation, first was the dehydration of alcohol. Second preparatory method is from alkyl halides. And this is again the name reaction. It is known as Williamson ether synthesis or only Williamson synthesis भी हम कहते हैं. Yeah. So it is from the alkyl halides you can prepare the ether. From alkyl halide means haloalkane से भी आप prepare ये ether form कर सकते. So that is the Williamson synthesis. When you prepare the ether by the use of haloalkanes, so it is known as Williamson ether synthesis. So let's see what we do in this reaction. So here, when haloalkanes is treated with suitable sodium alkoxide, alkoxide क्या होते हैं आपके? This one, suppose this is a 2 carbon group which is ethyl, and here ON. Okay, so sodium alkoxide. Sodium के साथ oxygen, when it is attached oxygen, and here the alkyl group. So this is your sodium alkoxide. This RO group. RO RO group basically इसे हम alkoxide कहते हैं, alkoxide. Alkyl with oxygen linkage is known as alkoxide. Okay, try to understand the meaning of this word alkoxide, alkyl plus oxide linkage. This is a RO group is the alkoxide, and when it is sodium alkoxide means RONA. This is a sodium alkoxide. So when haloalkanes are treated with sodium alkoxide, so here again SN2 reaction takes place, which forms corresponding ether. Okay, so that's a Williamson ether synthesis. See the general reaction. So this is a ROH, alcohol. अल्कोहल को जब आप ट्रीट कराते हो सोडियम से so you will get here again this hydrogen will be replaced by the sodium and you will get sodium alkoxide plus H2. Yeah, so now this sodium alkoxide को आपने किससे ट्रीट कराना है, your haloalkanes. So suppose this is your RONA, this is a sodium alkoxide and you are treating this with R dash X. Suppose this is the R other alkyl group and this is another alkyl group R dash. इसलिए मैंने R dash लिखा है. Okay, to avoid the confusion. R dash X. So this is the alkyl halide. So what happens over here? What happens? This have this oxygen because alkyl halide basically, you know, this X is the electronegative element, so this will acquire partial negative charge, and this R group will acquire partial positive charge. Okay. Now see similarly here, this oxygen has a lone pair, right? So means lone pair means negative charges के ऊपर, and sodium will have the positive charge. So again, positive को negative के साथ attach कर दो and negative को positive के साथ. It's very simple. So this oxygen will try to abstract this. Okay, this try to approach this alkyl group because it's a positive. Oxygen negatively charged, it has a lone pair. So it will try to approach this R group, alkyl group. And the sodium, which has a positive charge, it will try to make bond with the X. तो ये NX बना के वो remove हो जाएगा, वो bond बना लेगा उसके साथ, and you will get RO R dash over here, which is E. Clear?
Yes, ma'am.
Now suppose if in your exam they don't give you the sodium alkoxide, उन्होंने ऐसा कुछ reaction दिया, say the first example, they just give you the alcohol, okay, and in the first step they will give you sodium because in the first step you are just treating this alcohol with sodium and it will form sodium alkoxide, and after that the sodium alkoxide will treated will react with this second reagent which is CH3Br, and what is CH3Br is it's your alkyl halide. So it's a simple reaction. Just do that clearly. Just do that quickly. The mechanism is very simple. Done?
Yes, ma'am.
Okay, Muniba. Tell me the first answer.
CH3, CH2O, CH3 plus NaBr.
Very good. Plus NaBr. Very good. See the simple mechanism. What happens over here? This OH in the first step when it reacts with sodium. So here the substitution reaction will occur and it will form alkoxide, sodium alkoxide. Now in the second step, when it reacts with CH3Br, so you know B bromine has a negative charge and this alkyl group will have the positive charge. So this oxygen will have the yeah. So this will abstract this and this will abstract this. So you will get CH3 over here. So you will get so by this method of preparation, you can also prepare the unsymmetrical type of ether plus your NaBr. So that's a mechanism. It's quite simple. Similarly, second one. So already you have given the sodium alkoxide. So this oxygen, this bromine will have the negative charge and this whole thing. So here there will be a positive charge. So this oxygen will attack this carbon. Okay, because it has a partial positive charge and the sodium, because it have the positive charge, so it will attack this. So it will form O and 2 carbon. So again, it will form a symmetrical type of ether plus NaBr. That's the reaction. Yeah, there are more questions. Yeah, do this question. Third, fourth, and fifth. I will ask Safrina, Aisha, and Juditha. These three questions are for you. Third will Safrina will tell me the third answer, Juditha fourth one, and Aisha you will tell me the fifth one. Let's quickly do that. It's quite simple. Yes, Safrina. Tell me the first one, third answer. See, it's quite mechanism is quite simple. The plus minus का सिर्फ खेल है, right? The game of plus minus. See, you have to yeah. This is the oxygen will have the lone pair which is negatively charged, and this will have the positive charge. This chlorine, haloalkane में chlorine is electronegative, so this will have the negative charge. Partial negative आप show कर सकते हैं, and this carbon will have the partial positive charge. Now the simple funda is very simple. Okay, so unlike charges attract each other, right? So oxygen, which has a lone pair, it will try to attract this carbon, which has a partial positive charge, and the sodium will try to attract this one, chlorine. So यहाँ से NaCl will be formed, salt plus this group. This whole thing, this group I have drawn, this alkyl group. And here oxygen, okay, and oxygen से क्या आपने attach करना? This carbon. You have to attach this carbon will be attached to this oxygen. So this carbon, okay, so here this carbon, one, one, two, one, and two. So that's the whole thing. Okay, so this is your unsymmetrical ether in the first one. Clear?
Yes.
In the second.
Yes. Who asked me the question?
Aisha.
Yes, Aisha.
Can you explain this again?
Okay. The fourth one, according to you, this question.
No, the third one.
The third one, okay. Let me explain it again. So everything depends on the charges. See, this is your alkyl group over here. 1, 2, 3 carbon. This is your 3 carbon chain. Okay, and to second carbon, oxygen and sodium is attached. Second carbon पे क्या attached? Oxygen and Na. And you know, oxygen has a lone pair, which is negatively charged. What is lone pair? It's a negative charge. It is nothing but an electron. Electron is negatively charged. So it will have negative charge and this sodium will have the positive charge. Again, this is your alkyl halide. Okay, halogen will have the is a electronegative element, so they will acquire partial negative charge. Negative होते electronegative, so they will acquire partial negative charge. And this halogen is attached to this carbon, right? This carbon. So this carbon will acquire partial positive charge. Now it's quite simple. This oxygen, which is having negative charge, it will try to attach this on this carbon. ये इसके साथ attract करना चाहेगा this carbon which is a partial positive charge. And this sodium जिसके पास positive charge है, it will try to attract this chlorine. So sodium chlorine के साथ attract bond बना के ये sodium chloride बना लेगा NaCl. Salt will be formed. Now here this is first you will draw this 1, 2, 3, 3 carbon chain. And second carbon पे क्या attached? Oxygen. Second carbon, oxygen is attached. Now the sodium has been been removed from here. Okay, sodium ने किसके साथ bond बना लिया? Sodium chloride के साथ, and sodium chloride has been removed. So it has a negative charge, and इसके साथ क्या attached होगा? This carbon from here 1 and 2. So this whole thing, this alkyl group, this whole thing is the alkyl group, right? This chlorine will be removed from the sodium and the remaining is CH3. This is CH3, CH2. So oxygen से आपने क्या attach करना है? 1 carbon CH2 and this is your CH3. So that's the ether. That's the unsymmetrical ether. Clear now, Aisha?
Yes, ma'am.
Okay, so just try to understand the mechanisms. It will be very simple. Now do the fourth and fifth one. Again, it's very simple. Bromine के पास क्या होगा? Negative charge. This CH3 will have the partial positive charge. Okay, sodium it has a sodium will have the positive charge and the oxygen will have the negative charge, which is a lone pair. So it will try to approach this CH3 and sodium किसके साथ bond बनाएगा? Br के साथ. So here NaBr will be formed. Plus here this cyclopentane, and on this position oxygen, and oxygen के साथ क्या आ जाएगा? CH3. This whole thing. Okay, so you can write CH. So that's the product. That's the ether. Clear?
Yes.
Yes, ma'am.
Yes. Okay. Fifth one. Again, do the same thing. Oxygen के पास lone pair. It will have the positive charge. This bromine will have the partial negative charge, and this carbon will have the partial positive charge. So this will attach over here. Carbon which have the partial positive charge, and the sodium will attach over here. Okay, so sodium NaBr will be formed. And here this cyclic structure, cyclohexane. And and on this position, oxygen के साथ क्या आपने attach करना? This whole thing. Okay, when the bromine will leave this group, so what is the remaining? CH3, CH2. Okay, your ethyl group. So you have to attach this ethyl group. तो आप ऐसे attach कर सकते हो. One carbon and the second carbon. One and second. Yeah, or you can directly write down CH2, CH3. So that's the whole thing. Clear to everyone?
Yes, ma'am.
Yes.
Okay, now, so because it's again the SN2 type of reaction, SN2 mechanism ये follow कर रहा है, means the attack of nucleophile and the living group left the group, okay, left the compound. So elimination of living group and the attack of nucleophile occurs in the same step. So it's again a bimolecular nucleophilic substitution reaction. and you know what is the order. ये सब तो अब आपको याद होना चाहिए. Okay, it should be on your tongue, just like SN2 mechanism में बोलो तो what will be the order? 1, 2, 3, primary, secondary and tertiary. Right? If I say SN1 mechanism, SN1 हो रहा है, so what will be the order? So it will be tertiary, secondary and primary. Tertiary में सबसे ज़्यादा rate of reaction first होगा, then secondary, then primary. Yeah. So okay. Now the remarks. First point. So Williamson ether synthesis is an SN2 reaction. SN2 mechanism के through होता है, where alkoxide is nucleophile. What is nucleophile over here? So a nucleophile is this ONA, this alkoxide. This alkoxide is your nucleophile, right? This is your nucleophile. And Rx is the substrate. Rx क्या है यहाँ पे substrate, right? So this nucleophile attack the R group of the substrate, and X is the good leaving group, so just it left the group. So it's a SN2 reaction. Second thing, the haloalkane should be less hindered. Haloalkane less hindered होने चाहिए, ज़्यादा bulky group present नहीं होने चाहिए haloalkane. Right? So again, the primary halide, basically primary halide you will use. Basically prefer क्या करोगे आप? Primary halide, because see this is your Rx. So Rx is your primary halide, means halogens only one group is attached. So this is your primary one. So it is less hindered. There is no bulky group present. So this is a less hindered. So haloalkane जो होना चाहिए, the substrate for this reaction should be less hindered. Means you should prefer the primary one. Okay, not the secondary and tertiary, because secondary and tertiary will have the CH3 group, more CH3 group, and these are some bulky group. The CH3 group are bulky group, so due to that there will be a more hydration. Okay, more hydration की वजह से the hydration की वजह से you will get another product also. Okay, you will not get only one product, you will get another product also. So that's why, to avoid this, you should prefer only primary alkyl halides, which should be less hindered. Okay, so haloalkane should be less hindered. Third point, to form unsymmetrical ether form करने के लिए you should prefer primary alkyl halide. Okay, so for to form unsymmetrical ether, you should prefer primary alkyl halide because it is less hindered. Fourth one, usage of secondary and tertiary haloalkane leads to the formation of alkene as they are more hindered. Okay, that's what I told you. Because if you use the secondary and tertiary haloalkane, so there are more bulky group. And bulky group की वजह से क्या होगा? There will be more hydration, steric hindrance होंगे. And due to that, वहाँ पे क्या होगा? एलिमिनेशन रिएक्शन हो जाएगा. अदर देन न्यूक्लियोफिलिक रिएक्शन नहीं होगा, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन नहीं होगी, वहां पे एलिमिनेशन रिएक्शन हो जाएगा. एंड ड्यू टू द एलिमिनेशन रिएक्शन यू विल गेट एल्कीन. Okay, so that's why we just prefer only primary alkyl halide, not the secondary or tertiary one, for the formation of unsymmetrical ether. For example, so this is your ether. Now the question is, what will be the substrate and what will be the uh, nucleophile over here? So this is now sometimes क्या होते हैं, you will get the product, okay, and they will ask you what will be the reagent over here, reactant over here. Okay, so here what you are supposed to do in this type of reaction, this is unsymmetrical. Just try to first analyze the product. So this is an unsymmetrical type of ether. So here क्या है, here on the right side of the ether linkage there is C ethyl group, and here this is the iso group. Okay, यहाँ पे क्या है, isopropyl. 1, 2, 3. This is the isopropyl group. So you have to, for this type of reaction, because what we have, yeah, see the haloalkane. So here you know Rx is your substrate. Haloalkane is your substrate, and you know haloalkane जो substrate है, इसे हमें क्या लेना है, less hindered होने चाहिए. Less hindered means either you will prefer primary one, you will prefer primary alkyl halide. Okay, and your nucleophile is basically your alkoxide, sodium alkoxide. So there are two groups, so you will use two different alcohol. Okay, not alcohol. First you have to form the alkoxide, and the second one you have to form the alkyl halide. Halide. That's why due to these two reaction, when you know very well, this is the reaction of Williamson reaction. क्या होता है? Is the reaction of alkoxide with the alkyl halide. Alkyl halide, when it's treated with alkoxide, it will form the ether, unsymmetrical ether, right? So here you can first step. देखो first step क्या होता है? This is oxygen linkage. So here is a so here this is the alpha carbon. This is your alpha carbon. Oxygen से ये carbon attached. This is your alpha carbon. And again here is again alpha carbon. Now check which alpha carbon is primary. Which alpha carbon is primary? On the right one or left one? Again, this one is primary. This is your primary, right? This is your primary and this is your secondary. So जो primary alpha carbon है, so here from this alpha carbon, from this group, you have to make the RX. आपको ये group break करके ने इसे X join करना है. So this is your oxygen linkage है, and this whole thing, which is a primary alcohol, because you know substrate should be less hindered. Substrate हम किसे choose करेंगे? Primary alcohol, primary one को. Okay, primary alkyl halide should be preferred, okay, in the preparation of unsymmetrical type of ether. So this is a primary one. So 1 2 carbon, 1 2 carbon. So you will add 1 2 carbon, 1 2 carbon, and here you will add any alkyl, any halogen group. Okay, so I'm just adding bromine. आप chlorine भी लगा सकते हो, bromine लगा रही हूँ मैं. Okay, so either just use either chlorine or bromine. Okay, now, so here this is oxygen linkage, and on the right side there is a primary group. Alpha carbon is primary, and on the left side the alpha carbon is secondary. So you will choose primary alpha carbon, and उसमें आप क्या लगाओगे? Bromine group, any bromine or any halogen group you will add. So this is your substrate. Plus ये जो remaining group है, this whole thing, this remaining group में आप oxygen के साथ sodium लगाओगे. So this thing ONA. So that's the reaction. Now the reaction will proceed. This is your nucleophile, which is your alkoxide, sodium alkoxide, and this is your substrate, which is your alkyl halide. Now you can see the reaction will take place. Oxygen has a lone pair. Sodium will have the positive charge. This will have the partial negative charge. This will have the partial positive charge. So again, the same thing will happen, right? So here, from here, NaBr plus you will get the same product. This thing, O, and here 1 2 carbon, 1 2 carbon. So that's the product. So if sometimes other product दे दे and you were asked to write on the substrate and the alkoxide means you have to write on the reactants overall, so you can write accordingly. Okay, so you have to check which group. First analyze the product. Oxygen linkage is it is, and here the other group, which is a primary. You have to check which alpha carbon is primary. Okay, if it is primary, if the primary alpha carbon is present, then उसके साथ आप क्या attach करना है? Your halogen group. So basically you have to form substrate from that alkyl halide आपको बनाना है. And the remaining group, after making the substrate, the remaining group you have to add the sodium. So this is alkoxide. So and after that you can show the whole reaction according to this. So this is a Williamson synthesis. Clear to everyone?
Yes, ma'am.
So similarly, you will do this alkoxybenzene. Now, from which bond you will break, and from which alkyl group you will form the alkyl halide. अब किस group का? Again, you can see this is oxygen linkage, but here first हमने क्या बात की थी? First, both the group are alkyl group, but here one group is alkyl and one group is aryl. Now just think about it. Which bond you will break? This bond you will break or this bond? Which is possible? So this is alkoxybenzene. So how you will form alkoxybenzene? Okay, I'm writing two reactions. Now you guys will tell me in these two reactions, one is correct and one is incorrect. Okay, and you will tell me what will be the reason because you know very well. Okay, so first I'm just breaking this bond. ओके सो ये अल्काइल ग्रुप, इस अल्काइल ग्रुप के साथ में एक्स लगा रही हूँ एंड दिस होल थिंग के साथ में इन्हें लगा रही हूँ, दिस बेंजीन विद ऑक्सीजन लिंकेज. सो आई एम जस्ट ब्रेकिंग दिस बॉन्ड. इन द फर्स्ट स्टेप आई एम जस्ट ब्रेकिंग दिस बॉन्ड. ओके सो व्हेन आई ब्रेक दिस बॉन्ड, सो ऑक्सीजन के साथ में क्या लगाऊंगी, Na प्लस दिस R के साथ में क्या बना दूंगी, सबस्ट्रेट एक्स ग्रुप, एक्स ग्रुप. सो बेसिकली दिस इज अ फिनॉक्साइड. What is this? This is a alkoxide hota tha, and here this is a phenyl group. Okay, so we call it as a phenoxide on the reaction of phenoxide and and haloalkane. Second thing, if I break this bond, if I break this bond, so here I'm writing the product. If I break this bond, तो इसके साथ में RO के साथ क्या लगाऊंगी, RONA. Okay, I will make RONA. Okay, RO के साथ मैं अल्कोक्साइड बना रही हूँ and this benzene के साथ I will add alkyl, ये X group. Now tell me between these two which one is correct? Who will tell me?
The right one.
Right one means this blue color से जो मैंने लिखा है.
Yes.
Okay, so according to Aisha, this one is correct. Anyone? Just think about it. It's very clear. It depends on the bond, cleavage of bond. Just analyze it. Just think about it. Is it possible for the haloarenes to do the substitution reaction? Yes, Moniba, you should know. No one? See, this whole thing mechanism क्या हो रहा है? Nucleophilic substitution reaction. And you know very well, aryl halide में nucleophilic substitution reaction is not possible at the normal temperature, room temperature. Why it is not possible? Because this is, here you can see ये bond ही break करना possible नहीं है. This benzene ring के साथ ये जो oxygen link है, this bond, if you break this bond, so you will form this X, right? And you know very well this aryl halide will, basically there will be a double bond. Okay, there will be a partial double bond character between this carbon and the halogen group. Okay, so that's why nucleophilic substitution reaction is not possible in the haloarene. So this reaction is not, this is not possible. This reaction is not possible. Right? तो आप इस bond को break नहीं कर सकते. This alkoxybenzene में this bond, it is very difficult to break this bond. Why? Because this oxygen is involved in the resonance. It's involved in the resonance, right? And when it involves in the resonance, there will be a partial double bond character between the oxygen and this carbon. Okay, and you know double bond is more stronger than the single bond, right? So here what happens? Due to that, it is very difficult to break this bond. And you know, due to that, due to the partial double bond character, the nucleophilic substitution reaction in the haloarene is not possible. That's why this is incorrect. ये bond break ही नहीं हो सकता, right? So this is incorrect. So the correct one is this. You will break this bond. You will oxygen and this R group के bond को break करोगे आप. Okay, alkyl and oxygen bond को ना कि aryl and oxygen linkage. Yeah, so you will break this bond, and if you break this bond, so oxygen के साथ क्या आप add करोगे? Na. Okay, so it will form phenoxide ion. So this phenoxide, sodium phenoxide basically, phenoxide, PHE, sodium. It will form sodium phenoxide and your haloalkene. Okay, so you can just easily you can do this reaction. You can show here. This is your O, Na. So sodium, इसके पास lone pairs and sodium will have the positive charge and this Rx. So it will have the partial negative charge, partial positive charge. So this will, okay, now it's very easy. Now it will form the alkoxide benzene O and O के साथ R group plus your NX. So that's the alkoxy benzene. Is it clear to everyone?
Yes, ma'am.
Yes.
Okay. So second one is not possible. So in every time, if I ask you if it is possible to break this bond, so no, it is not possible. Okay, because this oxygen, if there is an any electronegative element, so this will always involved in the resonance. If it is always involved in the resonance, there will be a partial double bond tag. Okay, and it is very difficult to break this. Okay, so alkoxybenzene cannot be prepared using haloarenes. Why? Because haloarenes don't show nucleophilic substitution reaction. Okay, न्यूक्लियोफिलिक अब आप बोलोगे न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन तो करता है, हमने देखा है like in those process, but in the some harsh condition, but in some drastic condition like when you give high temperature and pressure, then only the nucleophilic substitution reaction of haloarine is possible. Okay, and that process is dose process. Again, that is very important. Yeah. So, but at normal temperature, the haloarenes don't show the nucleophilic substitution reaction. So, therefore, alkoxybenzene are prepared using phenoxide and haloalkene. Okay, now here's a question. Write the names of reagent and equations for the preparation of the following ethers by Williamson synthesis. Okay, just do this question quickly. You have to write down the name of reagents and equations with proper equations linear reactions. Okay, in the for the preparation of these using Williamson synthesis. So let's मैं उसका structure draw कर देती हूँ. One propoxy propane. 1, 2, 3 three carbon chain oxygen. 1, 2, 3. 1, 2, 3. So this is a one propoxy propane. Okay. Second one is your ethoxybenzene. Ethoxybenzene. So this is a benzene. This is oxygen linkage, and this is a ethyl group, ethoxybenzene. Third one is your 2-methoxy, 2-methyl propane. 2-methoxy, 2-methyl propane. So 2-methoxy, 2-methyl propane. Methoxy 2, 3. Because this is a CH. So 1, 2. 1, 2. So this is a 2 position पे क्या होगा? This is a methoxy. Okay, and 2 पे methyl पे, and this is a 1, 2, 3. So I'm just starting the numbering 1, 2, and this is your 3. So second position with this whole thing is methoxy. Second position for methyl B, and this is the propane. So that's the structure. Fourth one is your 1-methoxyethane. 1-methoxyethane. So that's the thing. ये तो मैंने show कर चुकी हूँ. Okay, I have already given this. Okay, now quickly do this. You have to write down the reactants. आपको break करना है, and you have to decide to which group. Means there are two groups. Oxygen linkage है right side group, left side group. आप किस group के साथ आपने substrate बनाना है and किस group के साथ आपने alkoxide बनाना है. You have to decide that accordingly. Okay, just quickly do that. Okay, so that's your homework. These 4 questions, write down and just draw the structure. That's your homework. And I'm just giving you one more question. Just note down over here. Yeah, this one question. Question is, tert butyl ether cannot be prepared by Williamson ether synthesis. Why? Just write down the question. Just try this question at your home, and I will ask you the product of these questions in the next class. Just write down and please update me.
Ma'am, can you show the above questions?
Yeah.
Done, ma'am.
Okay. So if you want to draw the structure, you can. Here's a structure. First, second, third. Second question you have written.
Yes, ma'am.